Configuration management is one of those skills that separates junior Salesforce developers from senior ones, not because it's conceptually complex, but because the wrong approach creates silent failures that only surface under pressure. A sandbox refresh before a go-live. A bulk trigger hitting governor limits. A deployment that wipes the values your integration depends on. Custom metadata types solve all three of these problems, and they're built directly into the platform. This tutorial walks through everything from initial setup to production-grade patterns. Here's a scenario that plays out in orgs every week. A developer refreshes a sandbox to prepare for UAT. Testing starts. 15 minutes in, someone notices the discount tiers are wrong or gone entirely. The feature flags are all set to false. The integration endpoints point nowhere. That's custom settings data behaving exactly as designed. It lives in the database, so when you refresh the sandbox, it doesn't come along. Every team that's been burned by this eventually discovers custom metadata types. The most common misconception about custom metadata types is that they're just a more complex version of custom settings. They're not. They're a fundamentally different storage layer. Custom settings are data. Custom metadata types are metadata. They live in the same layer as your Apex classes and object definitions. That means they're packaged, deployed, and version controlled exactly like your code. The distinction isn't cosmetic. It determines whether your configuration survives a sandbox refresh, a deployment, or a managed package install. A custom metadata type is a schema definition, similar to a custom object, but whose records are stored in the org's metadata layer rather than the database. Think of it this way. A custom object is like a table in a database. A custom metadata type is like a configuration file packaged into the application itself. The type definition, the fields you add, and the records you create all live in metadata. They deploy via SFDX, change sets, or the metadata API, exactly like Apex classes. The practical trade-off between custom metadata types and custom settings comes down to one question. Does this value need to change at runtime without a deployment? If yes, if an ops team needs to flip a toggle through the UI on a Tuesday afternoon without a developer involved, use custom settings. They support DML, so Apex can write to them at runtime. But if the value is stable configuration that should travel with your code through environments, custom metadata types are the right tool. Custom objects enter the picture when your configuration needs the full features of a database record, an audit trail showing who changed what and when, an approval process before a change takes effect, or relationships to other records. The trade-off is governor limits. Every SOQL query against a custom object counts against your 100 query limit per transaction. For stable configuration that doesn't change at runtime, paying that query cost on every transaction is unnecessary overhead. CMT eliminates it entirely. Creating a custom metadata type starts in setup. Search for custom metadata types, click New, and give it a label. The platform auto-generates the API name with __MDT suffix. That __MDT is how the platform distinguishes CMT from custom objects, which use __C. For this tutorial, we're building a discount tier configuration. Set the label to discount tier, let the plural label and API name fill in automatically, and save. You now have an empty schema ready for fields. Adding fields to a custom metadata type works the same way as adding fields to a custom object. Click New Field on the Type Detail page and choose your field type. For the discount tier pricing engine, we need 5 fields. min__C as currency, max__C as currency, discount_%_C as a number with 2 decimal places, is _active_C as a checkbox defaulting to true, and priority__C as a number to resolve overlapping ranges. Every CMT record also gets 2 system fields automatically, developer name and master label. Once the schema is set up, you create configuration records by clicking Manage Discount Tiers and then New. Each record is 1 configuration entry. For this pricing engine, create 3 records. Bronze tier covering orders from $0 to $500 at 5% discount, silver tier from $500 to $2,000 at 10%, and gold tier from $2,000 upward at 15%. The developer name, bronze_tier, silver_tier, gold_tier, is the stable identifier your Apex code will use. Master label is just the display label and setup. Salesforce auto-generates a typed Apex class for every custom metadata type you create, named after the type's API name. For discount__MDT, that class is discount__MDT. It exposes two static methods. GetInstance takes a developer name string and returns that single record, or null if the record doesn't exist, so always null check in production code. getAll returns a map from developer name to record, giving you every record of that type. Neither method consumes SOQL query rows. They read from the framework's metadata cache. When you need server-side filtering, for example, only active tiers or tiers ordered by priority, you can use SOQL directly on a CMT, just like a custom object. The syntax is identical. Select your fields from discount _dt, where is underscore active equals true order by priority and SC. This does consume query rows, so prefer getAll with in-memory filtering when your full record set is small, typically under a few hundred records. Use SOQL when the filtering logic is complex or when you only want a subset of a large collection. The static final caching pattern is how you make CMT lookups safe in bulk contexts. Declare a static final map at the class level, initialized with getAll. Because it's static final, it runs exactly once when the class is first loaded in a transaction, not once per method call, not once per record in a trigger batch. Inside your processing logic, you look up records from that map using get. That's a plain in-memory lookup, constant time, zero queries, completely safe to call inside a loop over thousands of records. Unit testing custom metadata is where developers hit a common wall. You can't insert CMT records via DML in a test class. They're metadata, not data. The clean solution is a test visible static field on the class under test. In production, that field is initialized with getAll. In your test class, you replace it with a map of in-memory CMT instances you construct with the new keyword. Building a CMT instance in memory is completely legal in Apex. You're just creating an S-object on a heap. No insert, no DML, no data dependency. One of the most underused features of custom metadata is native support in formula fields and validation rules. The syntax is $custom metadata, then the type API name, the record developer name, and the field name, all separated. That reference is resolved at compile time with zero runtime SOQL cost. A validation rule can directly enforce a minimum threshold by reading a CMT field value. The limitation: this only works for a specific known record. For dynamic lookups, finding the right tier for a given amount, Apex is required. In an SFDX project, custom metadata lives in two locations. The type definition, schema, and fields sits under objects /discount.dt/ as .field meta.xml files. The records live in custom metadata / as individual XML files, named type name, .record developer name, mdmeta.xml. Each record file contains the label, a protected flag, and a list of field value pairs. You deploy these exactly like Apex classes using SF Project Deploy Start. The type definition and all its records deploy together as part of the same operation, configuration, and code ship atomically. The developer name versus master label confusion causes subtle, silent bugs. Developer name is the stable API identifier. It's what you pass to getInstance and what getAll uses as the map key. Master label is the display label shown in setup. They start the same, but an admin can rename the label after creation. If someone changes gold tier to premium tier in setup, master label updates, but developer name stays gold_tier. Any code keying on master label breaks silently and returns null. Always use developer name in your Apex logic. Treat it as immutable once set. To build a feature flag registry, create a custom metadata type called featureflag_dt with two fields, feature_c as text and is_c as a checkbox. Create a static Apex class with a single is_enabled method. Inside, getAll loads once as a static final map. Then the method does a map lookup by developer name and returns the is_enabled value. Now any feature can be wrapped in a one-line conditional. To toggle the flag, update the CMT records XML and deploy it. No Apex change, no full code-based deployment required. Integration endpoint management is where custom metadata delivers some of its clearest production value. Create an integration config_dt type with fields for endpoint_c, API_version_c, and timeout_c. Create one record per external system, payment_gateway, shipping_provider, tax_service. Your Apex reads the config with getInstance, and sets the HTTP request endpoint and timeout from those field values. Each environment, dev sandbox, UAT, production, has its own version of those records and source control. Promoting through environments is a deployment, not a manual data migration. No copying. No risk of wrong endpoints in the wrong org. The one rule that ties everything together. Custom metadata types are metadata, not data. They move with deployments, not with data migrations. If you export a dataset and import it into a new org, CMT records don't come along because they're already part of that org's deployed configuration. The flip side, if you edit a CMT record directly in production setup as a break glass measure, immediately retrieve that change back into source control with SF project retrieve start. Otherwise, your repo diverges from production and the next deployment could silently overwrite it. The full article on Real Syllabus covers everything in this tutorial with complete, production-ready code, the full pricing engine with priority-based tier resolution, the @test visible injection pattern with 4 test cases covering bronze tier, gold tier, no match, and null input, the metadata API update pattern using deploy container for admin-facing configuration wizards, and the protected versus unprotected flag for ISV package development. If you're building on Salesforce and still have configuration hard-coded in Apex or scattered across custom settings without a deployment strategy, the article is where to start.